Hey, beginning programming, we are going to do a little bit of particle effects today. Particle effects. Particle effects are great and a good example of doing dynamic object-oriented programming. I guess particle effects are things like explosions and things that involve a lot of sort of detailed uh, bits of things flying off of some sort of fire or that kind of thing, cloud, whatever. And usually they would be a pain to do with arrays. Arrays are fantastic for many things, but if you had to make every little tiny particle at the beginning of your program and then have them sitting there kind of doing nothing but still using up computer memory and CPU cycles, that would be terribly inefficient. So in order to do particle effects correctly, we're going to learn about something called an array list. Before we do the array list, we'll just do some basics here, and then we'll make a class, the particle class, and then we'll see the array list and put everything together into one big sweet project. And it's just going to be a demonstration project. So I encourage you to do along with me, and then you can kind of tinker with the code a little bit. This is definitely going to be the foundation for the next project. So take a look and see if you can make it work, and also if you can make sense of it. So to start with, we'll do good old void setup, void draw, and we're going to want to do size whatever number you want. 600 seems reasonable. I'm also going to add in FX2D. What is FX2D? It is a rendering engine, and it's a little bit more powerful than the regular one. If you were to put no parameters, the regular one's pretty basic. We're not going to do anything super sophisticated today, but might be nice to have a little bit of rendering power just to make sure this goes smoothly. I'm going to make a new class now. It's going to be the particle class. So I'm going to make the tab called particle. So what this particle is going to be is I'm just going to make it an ellipse for now, but no reason we couldn't make it, a picture or something later on of some fragment that's going to fly off. Then explosion. I suppose we'll make it an explosion eventually. But this will just be a single particle in that explosion. So I'm going to make class particle, and particles are pretty much going to be like a lot of things we've done so far. They'll have an X and a Y, and a VX and a VY. I think I won't bother with color right now, but that might be a nice thing to add in at some point. Maybe I'll add in a diameter as well. That might be a nice thing to include. Alright, so then our particle needs a constructor. We'll start off with X is just going to equal to mouse X, and Y is going to be mouse Y, so these particles will come out of the mouse as our starting thing we're going to try. And we'll randomize VX and VY. Make sure it can go in all directions. That will be good. Excuse me. Alright, so that's good. Diameter, oh sure, let's randomize diameter as well. Let's make it random, oh I don't know, 10 to 30, something like that. I don't know, 5 to 30. Okay, so there's some constructing going on here. This is the default values of a particle. It's just a single little thing. What does it look like? For now, this is going to be an ellipse. Oh, guess whatever color you want. I'll make it a white ellipse. And it will be, of course, X and Y will be its location, and we'll make it a perfect circle. And then we'll make an act function. And particles are just going to move. There's going to X equals X plus VX, Y equals Y plus VY. Nothing too exciting on its own, but we'll start combining particles together to make explosions. So we can do some fun stuff coming up with that. Let's take a look, I guess. I'd like to go and put particles in. So over in our main tab, I'm coming back. We are going to actually, create some kind of thing for particles. And if we made an array, that'd be a little bit awkward because we'd have to go and make hundreds of particles ready to go at any given time, and it would just get really annoying pretty fast. So what we're going to do instead is make an array list. An array list is like an array in concept. It's a super variable that stores many copies of the same type of thing, but what makes it different is that it can grow and shrink. And growing and shrinking is very, very valuable for all sorts of things, especially particle effects, so that when particles go away, then we can remove them, and when we don't need them, there just cannot be anything at all inside of this array list. So that's a big advantage. So we're going to do this. We're going to make an array list. Just type in the word array list, and then you type the type of thing. You write to the type of thing that they're going to contain. So that would be a particle. And a good name for this list? Well, trying to think of a name that will make things a little less confusing, because it's easy to get these confused. I'll put, I call this my particle list, I guess. It's a long name. It's up to you what you want to call it, I guess. Particles would be fine, but this will keep it from being a little less obvious as to, or a little more obvious as to what's the name of the list. So that's great. We actually have to instantiate this, and it looks pretty ugly as well. So you would say my particle list equals new. Sorry, I'll just get that very clear. Array list particle. Parentheses. Wow, that's a pretty ugly bit of code, but what this does is make a list that's ready to go and ready to add things to. And that's all we need to do. If this was an array, we would have to go now, loop through the entire array and fill all of its spaces or elements with new particles, but we don't have to do that with a list. The list simply will be empty until we add in new particles. What I'm going to do now is I'm going to write that loop that is going to animate the particles in the draw function. So we'll put in a background, I'll make it black, I guess. Doesn't really matter. And what this will look like is basically good old while loop, just like everything. Our while loop will pretty much, have some condition, which we'll talk about later. It'll, process the list will be the main thing, but then I equals I plus 1 will be the next part of it. And, something like, well, I is less than whatever the length of the list is will be sort of the structure of this list. Very similar to pretty much everything that we've done with arrays. So, that doesn't change a whole lot. There will be one change, though, and that is n. Usually when we made an array, we would choose how many things would be inside of it, but we don't know how many things are in this array list. Could be 0, could be 100, and it's going to grow and shrink as the program runs. So we have to replace that with something that can change. So what we're going to do is just the name of the list, my particle list dot size, and it's a function, so you have to include the parens at the end. So this basically gets the size, how many things are in the list. So that works out nicely. As this changes, the while loop's condition will change. And just to mention, I think we'll actually print that out on the screen so we can see what's the number of things that's in our list. So I'll just fill with some red or something, just some other color to make it obvious. I'll make some reasonably large text size, and we'll do some text where we'll print out my particle list dot size. And we'll just do that at some number like that. All right, so that'll allow us to see how many things are in our list, and if we were to run this, I think we would find that we just get a big old red 0. Here we go. There's nothing in our list. It's just pure empty blackness. It's the void of nothing. And all of our code is useless. So actually this is an important uselessness, however. Previously, if we had used arrays, even if we didn't want any particles at the beginning, we would have to have made them all. And so this number would be much higher than 0, and they'd all be doing things and dancing around, and they wouldn't be on screen necessarily, but they'd all be being processed. So this is fantastic that we can have this empty void. So we'll come back to the empty void later on. Let's see. We're gonna go ahead and do something with these particles, I guess, in the event that we actually get them animated, or we actually add them to our list. So this is a bit tricky. Normally, this is the line of code. We do something like this: my particles list sub, I dot show would be the way we would do that, and a similar kind of thing for dot act, right? This is how we would normally do this if this was an array. So we want to do something similar, but that's just not what it looks like in an array list. So we'll show you how to do that type of code with the beautiful array list. And the way you do it is with the get function. So you can say my particle list dot get, and you can give it the index, so we'll get I. And whatever we get out of that list will be a particle. So we can store it in a temporary variable, like a particle variable. I'll just call it P. It's a temporary variable. And as we go through all the particles in our list, eventually, we hope to have some in our list. We'll just get them one at a time, starting with 0 and going up by 1 each time. And each time we'll call it P. And what do we do with P? Well, we make it show. Show. There we go. And we make it act. So now we are properly, animating all the particles in our list. Still, nothing will happen if we run this because we have no way of adding particles to our list. So we'll go do that now. This will be a pretty, simple piece of code actually to make this happen. I'll make a void mouse released, I suppose, function. And here, when I click and release the mouse, I will have it create a particle and add it to our list. So let's do it. I'm simply going to say if the mouse is released, I'm going to tell my particle list to add a new particle. That's a beautiful line of code. The other ones are pretty ugly, but this one's pretty nice. It just reads like English. Here, this new particle, that's us calling the constructor of the particle class. So we'll construct a particle and then add it to this list. And once we add it to the list, it'll start showing and acting. It'll be great. Let's go and run it. Let's see if it works. Ooh, here it comes. Yes. And if I click, whoa, there's a particle. And the count goes up by 1. 2, here, I'll click a lot. It's hard to click fast. We're getting all these little particles that are flying off. So we now have 43 particles, and that's great. We could keep on going. Eventually we'll start lagging out though, and it's great that this list can grow, but it's almost even more important, or just as important, that it can shrink as well. So all these particles that have flown off of the screen, it would be nice if we could get them to maybe just cease to exist, so they don't use up any computer resources. So we'll do that. And actually, let's just see. Maybe I'll maybe we'll make 100 particles just to see if it gets terrible. So this isn't actually important. 1,000 particles? Wow, might as well. Let's make 1,000 particles every time I click the mouse. I equals I plus 1. 10? 1. Ooh, very hard. Okay, just to see what this looks like. Let's run it. Okay, here comes 1,000 particles. When I click, oh, pow, there goes all the particles. So 1,000 particles in our list. Some of them are very slow, some of them are very fast. I'll click again. Pew, click again. Pew, we got so many particles. And 5,000 particles right now in our array list. It's still pretty smooth. If you are running this on the school computers at this point, it's probably not smooth, I'm guessing. So I'll keep going. And we're at 10,000, 11,000. It's good advertisement for the MacBook Air, I suppose. But even now, you can see 16,000 particles. It's starting to get pretty choppy. You can see the frame rate has dropped considerably. Maybe it would have been smart to print out the frame rate. Feel free to do that for the school computers and laugh at them as they struggle mightily to render 16,000 particles. And most of them aren't on screen anymore, but they still exist. We're still adding their numbers and stuff, so it's causing all these particles to be now quite choppy. So how do we get around that? How do we fix this? So it turns out you can not just add particles, but you can remove them as well. And so what we can do is in our particle class, create some sort of a system for determining whether or not our particles are still alive. And when they are no longer alive, we can remove them. So I'm going to make a function called isAlive, and it's going to be a Boolean function. You might recall these types of functions from when we did coding back questions, and they return true or false. So they basically answer a true or false question. So isAlive is a true or false question. Is this particle alive still or not alive? And how I'll determine whether they're alive or not, I'll just check to see if they're on the screen. So I'll just say if their x-coordinate is greater than 0 and the x-coordinate is less than the width. You could adjust these for the diameter a bit, because otherwise they'll just poof right off the edge. But I'll leave that to you to decide if you want to do that. If y is greater than 0 and if y is less than the height. Again, adjust for diameter if you wish. If that's all true, then I'm going to return true, because it's still alive if it's on the screen. Else, if it's off the screen, I'm going to return false. And so now a particle, when we're in the array, I don't actually want to save it, sorry. When we're in the array, we can ask, hey, are you alive? And if you're not, we will remove you. So you're not using up our system resources. So in our draw function, in this while loop, where we are processing particles, we are going to add in a little if statement. We'll say, hey, if p dot is alive equals false. If it's no longer alive, then we're going to remove the particle. My particle list dot remove I. It's going to remove the particle at index I. Now, this is super complicated and much easier explained with a diagram, so I'll probably defer to when I return to class just to make this clear. But it turns out when you remove something from the middle of a list or beginning of a list or pretty much anywhere than the end of the list, all of the elements further down the list all have to renumber themselves. For example, if you have a list that's like, index is 0, 1, 2, 3, 4. If you remove element number 1, then number 2 becomes a new number 1, and number 3 becomes a new number 2, and so on. So there's this renumbering that happens, and basically that means that we don't need to do the I equals I plus 1. We don't have to move forward if we remove something, because the next thing is going to come to us. So we're just going to offset this I equals I plus 1 with I equals I minus 1. And it's kind of beyond grade 10 stuff to worry about that, so I wouldn't worry about it too much. Oh yeah, I'm not going to save. I've just got the habit of saving, but you guys probably should be saving as you go. So this is what will allow our particles to get removed. And we can watch and see if they get removed. I'll go ahead and run this. I'll click on the sparkle or the screen and our sparkles will come up. And you can see this number is drastically reducing as these fly off the screen. So theoretically, I can just click forever, and this will get to high numbers, but will also come back down. So all these explosions of particles will stay manageable. We'll never really lag out our computer. I guess if I click fast enough, here I am going pretty crazy. I'm getting it up into the 10,000s. So, that's pretty lag-inducing, I suppose, but not too shabby. Not too shabby. And eventually it returns to a manageable state again of, sub 1,000 particles. And yeah, so that's pretty nice. That's pretty useful little, way to collect things. So there's some particle stuff. I went through that really fast, so I'm hoping that you will try this out. This is especially the new stuff here. Oh gosh, there's so much interesting stuff we can do with this. But first time through might not be clear, so please make sure you think of some questions. Feel free to ask each other these questions. See if you can help each other with them. If there's anything you're not too sure about what's going on. And by the way, just because it works doesn't mean it makes sense to you. So make sure even if it works, you still come to me with those questions, because it's just a hard new thing to do. If it wasn't a collab day, I'd probably go and tell you some more stuff about this, but I think it's probably enough to digest just for today's class. For an extension activity, I would suggest maybe try to get your particles to differentiate in other ways. You can give them colors. You can make them prettier. You can try to add on some, I don't know, I'm losing my train of thought. I guess there's one other thing I wanted to show you was gravity, but I think we'll save that for when I get back. Okay, so thanks everybody. Try and get this working. Add on some extensions. Oh yeah, make it maybe instead of an ellipse, make a picture or something. See what you can do to make these particles lovely. Thanks everybody. I'll stop the video.